Before you start, answer these pre-lab questions. What is specific heat? Specific heat is the amount of energy needed to raise the temperature of 1 gram of the substance by 1 degree Celsius. If a heated piece of metal is placed into a styrofoam cup containing water at room temperature, where does the metal's heat go? The metal's heat goes into the water. What is the equation for the specific heat of a metal? Q equals Cm delta T. Step 1. Gather all your equipment as stated above.
Step 2. Fill beaker about 2/3 full of water.
Lindsay 600 milliliters. Turn hot plate on to dial 9.
Then put the beaker on it. Weigh metal 1. Record and chart. Record the mass of both empty foam cups. Record the mass of foam cups with water. Add both metals to boiling water.
Record the temperature of the water in the cups. Record the temperature of the boiling water in the beaker. This is considered to be the temperature of your metal.
Carefully but quickly remove the metals from the beaker and place them in 2 separate foam cups. Measure the highest temperature reached in each foam cup. This is considered to be the final temperature of the system. Repeat steps 2 through 8 for a second trial.
After completing the second trial, take the average of all your data.
Action.
Whoa, didn't see you there. Going over our post lab. Want to learn something?
Information from question number 1, identify each of the metals. By using these equations, we can identify that number 1 is zinc and number 2 is lead. Question number 3. Given the values that the math predicted for the specific heat capacities of the metals, calculate the percent error for each. The formula for percent error is experimental minus theoretical over experimental times 100 to get a percent. For zinc, the actual specific heat is 0.387. So here is how we found the percent error. For lead, the actual specific heat is 0.128, and here's how we found the percent error.
Number 4. Discuss 2 possible sources for error in this experiment. Number 1. The metal was touching the bottom of the beaker, which was directly touching the hot plate. This could have heated up the metal prematurely. Number 2. We left the metal in for longer than 5 minutes. Number 5. What other physical properties could you use to help identifying the samples used in this experiment? Density, color, conductivity, melting point, and crystallization.
6. Why is water an excellent material to use in a calorimeter? Water is an excellent material to use in a calorimeter because it has a very high specific heat. This means that it's hard for water to raise its temperature by even 1 degree.
Number 7. Calculate the specific heat of a metallic substance if 314 joules of energy are needed to raise the temperature of a 50 gram sample gram 25 degrees Celsius to 50 degrees Celsius. Show all your work. But I don't know how to do it, so I don't know.
I know how to do it. The formula is Q equals MC delta T, where Q is the energy, M is the mass, and C is the specific heat, and delta T is the change in temperature. You plug in all your values and solve.
Thank you.
We all say it in
Okay,
unison.
so hope you enjoyed our specific heat lab.
Okay.
And then Taylor go like that, so we're unison. No.
No.
Yeah. Sounds good. Are you ready? I'm still on my face.
Yeah, you can do that.
Yeah.
Yeah.
I gotta do T.
And-
Hey.
ahead. Go.
I know. It's going, by the way.
Oh,
Oh.
hope you enjoyed our
Specific
specific
heat
heat
lab.
lab. Hey, we're done.